This is the lesson plan that I've created for 8th grade Algebra 1. The standard that I chose is based around learning the slope-intercept formula of a linear equation and comparing linear equations to nonlinear equations. After this lesson, students will know the variables in this formula, they will know how this formula defines a linear equation, we'll be able to graph linear functions, and we'll be able to distinguish between linear and nonlinear equations. The exact state standard that I chose for this lesson was 8.AF.5. Interpret the equation y equals mx plus b as defining a linear function whose graph is a straight line. Give examples of functions that are not linear. Describe similarities and differences between linear and nonlinear functions from tables, graphs, verbal descriptions, and equations. Before the lesson begins, I will do a recall session based on the previous lesson's materials. The students will be asked to recall what a linear equation is, and they will review ordered pairs by volunteering to come up to the board to remind classmates how to graph coordinates. I'll then give them an overview of today's lesson. Materials needed for this lesson would be masking tape, bean bags, flashcards, a whiteboard, an expo marker, a worksheet, scissors, stapler, and for the students they would just need a notebook and a pencil to write with. So here's an example of what the board would look like during the pre-lesson recall session. I asked them if they remember what a linear equation is, giving them time to answer, and then I would write the definition on the board. A linear equation is an equation containing one variable with an exponent of 1 that graphs a straight line. I would then review ordered pairs by drawing a graph on the board and a few coordinates, and then I would have the students volunteer to come up and plot those points on the graph. This would transition into the lesson about linear equations in slope-intercept form. For direct instruction, the students will take notes from the whiteboard as I write examples like any normal math class. It will not be a long lecture, but I will go over several examples as this is necessary in understanding math. I will introduce them to the new slope-intercept formula, and I will use the examples that I give in order to refresh their memory on slope and coordinate pairs. We will use some examples to distinguish between linear and nonlinear equations. I will also draw a Venn diagram on the board asking the students what they remember about linear equations and how they think they differ from nonlinear equations. We will fill it out as much as possible, and then I will fill in the rest from the explanations if they have any questions. I would start with a Venn diagram comparing the two types of equations to help students distinguish one from the other during the remainder of the lesson. This is an example of what it might look like. Next, I would write a series of equations on the board, some linear and some nonlinear. The students and I would go down the list distinguishing each equation between linear and nonlinear. If an equation is nonlinear, the students would be asked to explain why. Now I would introduce the new slope-intercept formula, labeling and explaining the parts of it. I would explain that the m variable represents the slope, which is the rise over run or the rate of change. The b is the y-intercept, which is where the line of the equation intercepts or crosses the y-axis, and that the x and y represent any coordinate on the line. I would allow time for students to ask any questions that they might have. We would then dig right in with a few examples that will help in understanding the new formula. We would begin with an easy standard slope-intercept equation, and we would learn to use the slope and the y-intercept to graph it. For the next example, we would have to put the equation into slope-intercept form before graphing it. For the last example, we would be given bits of information about the equation of the line, and we would solve for the slope-intercept formula, then proceed to graph. This will help the students gain a deeper understanding of where the formula comes from. Here are some pictures of what this might look like on the board. Typically, I would give the students a myriad of examples involving negatives in different situations that they might find in their homework problems or in the problems on the unit test, but for this mini lesson, I have only shown a few that I would demonstrate for this topic. In math, it is important to practice a variety of examples in class so that the students have the opportunity and the time to ask the questions that they need, and so that they have a chance to do their homework problems correctly. After working out some examples on the board, we would watch a short video in order to give some differentiated instruction. Sometimes hearing more than one person explain the same thing in math can have a huge impact on a student's understanding of a concept. I found a video that is enthusiastic and grabs the attention of the viewer and also explains the concept very well. For the first activity, the students will be given a worksheet that they'll have to cut apart and staple together. This linear equation flippable will be a physical breakdown of the slope-intercept formula that the students can practice with. They can flip from variable to see what it is and how it is used, and they can flip to the back for an explained example of a linear equation graphed out. For the second guided practice activity, there would already be a graph taped out on the floor. The students will graph linear equations on this life-size graph by plotting the coordinates with beanbags and by actually walking out the rise and the run for the slope. Flashcards will tell them which equations to graph. I think this activity would be great for kinesthetic learners. So for the wrap-up and closure portion of this lesson, I would have the students complete an exit ticket before leaving for their next class. They would be given this large note card, like the picture shown, and they would have to derive the slope, y-intercept, x-intercept, and they would graph the linear equation. This will give me the information that I need to see how successful the lesson was and how well the students understood it. They'll hand this in on the way out of class. The other note card that they would be given would have a graph on it that shows some sort of statistical information. They will take this with them as part of their homework, and they will return to class with a possible explanation of what this graph represents. This will also serve as an introduction into the assessment portion of the content. For homework, the students will be assigned a few problems from their textbook in order to show their understanding of the content. They will have to show their work, and the work will have to be as neat as possible. Homework will never be graded on correctness, but it will be graded on completion and effort. At the beginning of the next class, I will ask them for any questions on these homework problems, and I will work them out on the board before beginning class. The problems that I will assign will essentially include determining if the graph is linear or nonlinear and why, graphing a line of linear equations, and listing the similarities and differences between linear and nonlinear equations. The students will have some problems that will need to be put into slope-intercept form before they graph it. This homework won't be extensive, but it will reinforce what they learned in this lesson by practicing problems on their own. For my students' project, I would have them research and choose a social or economic issue. They will research statistics and graphs surrounding that topic, such as low socioeconomic status areas and their relation to student test scores, and then they will create a poster that shows and explains how they took the data and determined whether it was linear or nonlinear, and they will propose an action that could be taken to improve the issue. I think that this would be a great project because a lot of the time math students have a hard time relating math to the real world, and this will give them a chance to relate linear equations with real-world issues. The students in Philly created a website and flyers to post around the community that they researched in order to inform students living in these communities that there are free SAT prep courses available that they probably didn't know about. So this project is a great way to integrate math into the real world by getting students actively involved in their community. Alright, so that was an overview of my 8th grade Algebra 1 lesson plan on linear equations. Thanks for watching.